All right, guys, so what we're looking at here is the particle motion example from 2018. You will have your calculator on this problem, so there's nothing to worry about there. So let's go ahead and get started on this thing, okay? So we've got a particle moving along the x-axis. Again, that tells us that we're looking at a particle motion problem. And it gives us a velocity function. And again, that's important that we understand that's a velocity function and a time interval as well. And then they give us the particle's beginning position. And notice again that happens at time equals 0, which will be important when we get further into the problem. So letter A says find the acceleration of the particle at time equals 3. Well, in order to find the acceleration, we just need to take the derivative of the velocity and then plug 3 in. So really I want to go v prime of 3. Now don't try and do that by hand. Because we have a calculator here, it's much easier to just let the calculator do the work. Remember, we press Math 8, type in the function, and then type in that it's happening at x equals 3. And when you do that, you should have gotten negative 2.118 for letter A. Again, pretty easy, I thought. Nothing that's overly difficult on that one. Just make sure that you don't try and take the derivative of that by hand. That would just be really difficult. You have to use a quotient rule, and there's a lot of places you could screw that up. But your calculator will do all the work for you. Letter B wants to know what is the position of the particle at time equals 3. Well, position, remember, is initial position plus the integral from A to B. Now, remember, time A is the time that they give you the initial position at. Time B is the time that you want the position of the particle at. And then we just put in that same velocity function. So I'm going to do that function right there. When I type that into my calculator, the number that we get there is negative 1.760. There's nothing wrong with getting a negative number. That just indicates that it is further to the left from where it started based on the information, not from where it started, from where it lives, based on the information that we are given. So there's nothing wrong with having a negative position as an answer. Letter C says evaluate the integral from 0 to 3.5 and do the same thing with the absolute value of our velocity function. When I put the first one into my calculator, I get 2.844. And when I do the second one, I get the absolute value of v of t. Oops, forgot the last one there. You get 3.737. And then it says interpret the meaning of each integral in the context of the problem. Well, the top one is just the displacement of the particle from, and always remember to say your intervals from 0 to 3.5. If you forget the t, you'll be okay. Or if you say x instead, that's also fine. When you put absolute values around the velocities, that is the total distance traveled from the same time. Okay, so we want the total distance traveled. Again, that's more just checking your knowledge. Now, honestly, when it says interpret the meaning in the context of the problem, as long as you use the word displacement and total distance traveled, and you include the time interval, you really should write it on both of them, then you'll get the interpret the meaning part just fine. It's not asking for it moves in this direction, then it moves in that direction, or it's always speeding up or slowing down. All it wants when it wants to interpret the meaning of the integral is, what did I just find? And as long as you use those words, you're totally fine on letter C. Letter D says the second particle moves along the x-axis with the position given by this. Now notice this is a position function. Okay, so the first one gave me a velocity function. The second, letter D, is giving me a position function. And it wants to know, well, what time are the two particles moving with the same velocity? Well, I have the velocity for particle A, if you will, or the first particle. The second particle, though, I do not. I need to find the velocity by taking the derivative of that particular function. You need to write that down. You can't just assume that they know that you did that. You need to find the velocity, and then we're just going to set those two velocities equal to each other. Well, again, without a calculator, that is very, very difficult. So what I need to do is in y1, I'm going to graph the first v of t, and in y2, I'm going to graph the second v of t. Then on this time interval, so you're going to want to change your viewing window. On that time interval, we're going to want to find out where the first velocity is equal to the second velocity. The way that we do that is we hit second trace number 5. We are looking for an intersect point, not a 0. Make sure you hit that enter button 3 times so it actually tells you an intersect point. And it just so happens that that is at 1.571. Hopefully, again, all of that made sense on all of those problems. Very heavy use of your calculator here, so make sure you have that down. If you have any questions, let me know.